Hearty welcome back to Math Revision Made Meticulous video series. Topic of this video is inverse trigonometric function. Let us see the principal value and graphs of inverse trigonometric function. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per video from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. Let us now see what do you mean by inverse of a function. For the function f from a to b, the inverse is the function g from b to a. For example, we are having a to b now, and the inverse is from b to a. The inverse of the function is denoted by f inverse x and read as f inverse of x. A function f of x will have inverse only if it is 1 to 1 and onto. Already we have seen in the previous chapter what do you mean by 1 function and onto function. A function to have inverse, it should be both 1 and onto. It should be a bijective function. Now let us see the inverse of sin x now. Let us see the inverse of all trigonometric function one after the other. But basically when you see the function f from r to r given by f of x is equal to sin x is neither 1 nor onto. Because all of you know that it is not 1 because f of 0 is also 0, f of pi is also 0, and similarly on the right hand side only from -1 to 1 will have pre-images, therefore it is not onto. Therefore, how to have the inverse now? To have the inverse, we have to restrict the domain and codomain to make it 1 to 1 and onto. How we are doing it? To have inverse of the function given by the domain r to r, the domain is to be restricted so that no two elements will have same image, and the codomain to be restricted as the range of f. This is a technique. We are going to restrict the domain such that no two elements will have the same image, and not only that, we will restrict the codomain equal to the range of f. Therefore, we are taking f from r to r given by f of x is equal to sin x by restricting the domain as minus pi by 2 to pi by 2. Therefore, apart from that pi by 2, if it go to the second quadrant, again the sign value will repeat. Therefore, we are taking only from minus pi by 2 to pi by 2, and we are taking the range of sin x, that is -1 to 1, as the codomain. Therefore, the function from f from minus pi by 2 to pi by 2 to 1 to 1 given by f of x is equal to sin x is now 1 to 1 and onto, and automatically it will have inverse as per the condition. And the inverse of sin x from minus pi by 2 to pi by 2 to -1 to 1 is given by f inverse from -1 to 1 to minus pi by 2 to pi by 2. Very simple. But we have to remember that there are so many sine functions which are having different types of domains and codomains will be always 1 and onto. Some of them are minus 3 pi by 2 to pi by 2 to minus pi by 2 to -1 to 1. Similarly, pi by 2 to 3 pi by 2 to -1 to 1. And like this, you can have a lot of branches. Then corresponding to each of these intervals, we get a branch of sin inverse x. We are just showing it on the figure now. For every interval, we will have a branch. What we are going to do now, we are going to take the branch of sin inverse x with the range minus pi by 2 to pi by 2 is called the principal value branch. We are taking only that minus pi by 2 to pi by 2 range as the branch which we want, that is called the principal value branch. When we refer the function sin inverse x, we take it as a function with the domain as -1 to 1 and range as minus pi by 2 to pi by 2. Now this is the graph now. Let us see the graph in a clear picture. Now this is the sin x graph. All of you are knowing that 0 to pi by 2 it goes like that, and this is the sin inverse x graph, and all of you are seeing that it value lies from -1 to 1 and it goes from minus pi by 2 to pi by 2. Good. Let us go to the inverse of cos x. The same thing. Cos x is neither 1 onto. Therefore, we have to restrict the domain and the codomain. How to make it? The domain is to be restricted so that no two elements will have same image. Codomain is to be restricted to the range of f. Therefore, we are taking f from r to r given by f of x is restricted as the domain is 0 to pi and the range is -1 to 1. Therefore, this function will be now a 1 1 and onto function. Therefore, this function will have a inverse given by cos inverse x from -1 to 1 to 0 to pi. As usual, there are so many cosine functions which are also 1 1 and onto. We are seeing that minus pi to 0, pi to 2 pi, then 2 pi to 3 pi, all of them, when you make them as the domain, they also will be 1 1 onto, they also will have inverse. Now we are having corresponding to each of this interval, we had a branch of cos inverse x. We are showing it in the figure now. And we are going to have the principal branch. That is the branch of cos inverse x with the range 0 to pi is called the principal value branch. Therefore, we refer the function cos inverse x, we take it as a function with the domain as -1 to 1 and range as 0 to pi. Now we are showing the cos inverse curve now. This is the cos x curve and this is the cos inverse x curve. Well, now let us go to the tan x now once again. As usual, tan x is neither 1 1 or onto. We have to restrict the domain and codomain to make it as 1 1 onto. How we are restricting? We are restricting it from minus pi by 2 to pi by 2 as the domain, and the codomain is the total real number system, therefore it will become onto. Therefore, the function f from minus pi by 2 to pi by 2 to r given by f of x is equal to tan x is now 1 1 onto, and it will have inverse. How to define the inverse now? We are calling it as tan inverse x. Therefore, f inverse of tan inverse x will be from r to minus pi by 2 to pi by 2, both not included because tan pi by 2 is not defined. But we are not taking minus pi by 2 to pi by 2. As usual, tangent function, so many tangent functions will also be 1 1 onto. We are showing it over here. Therefore, for every branch of it, we will have a branch of tan inverse x. We are showing it in the figure now. Minus 3 pi by 2 to minus pi by 2, there is a branch. Pi by 2 to 3 pi by 2, there is a branch. 3 pi by 2 to 5 pi by 2 also, there is a branch. So many branches are there. But we will take one branch as the principal branch, that is nothing but minus pi by 2 to pi by 2. For when we refer the function tan inverse x, we take it as a function with the domain as r and range as minus pi by 2 to pi by 2. Well, inverse function of tan x is like this. This is tan x function and this is the tan inverse function. We are seeing that it is not touching pi by 2, going very close to pi by 2, pi by 2 to minus pi by 2. Well, as usual, we will go for cosecant x. As cosecant x is not a 1 1 onto function, we are converting it to 1 1 onto by restricting the domain and the codomain, and we are taking the domain as minus pi by 2 to pi by 2 minus 0 because cosecant 0 is not defined, and the codomain as the range of f and okay as r. Therefore, here also r excluding minus 1 to 1. Therefore, cosecant x will not have value from minus 1 to 1. Therefore, we are restricting it. Is now 1 1 onto now. Therefore, the inverse is cosecant inverse x from r minus minus 1 to 1. That is all real numbers except the real number lying between minus 1 to 1 from minus pi by 2 to pi by 2 to minus 0. Therefore, following cosecant function also will be 1 1 onto. We are having a branches. Corresponding to each of this interval, we get a branch of cosecant inverse x, that is a figure for this. But out of them, we are taking a principal branch. Therefore, the branch is minus pi by 2 to pi by 2 minus 0. We are seeing that all these principal branches are centered around the origin. Okay, when we refer a function cosecant inverse x, we take the domain as r minus of minus 1 to 1. That is set of all real numbers except the interval, open interval minus 1 to 1. And the range is minus pi by 2 to pi by 2 minus 0. Therefore, this is the graph now. Now, let us take the graph of cosecant x. This is the cosecant x graph and this is the minus cosecant x graph. We are seeing that how it is going. Minus 1 to 1 is not included there and it goes from minus pi by 2 to pi by 2. The values of minus 1 to 1 is not there in the graph of cosecant inverse x. Good. Let us move on to the secant x. As usual, secant x is not 1 1 onto. We are restricting the domain and the codomain. Here we are taking r minus 2n plus 1 pi by 2 because for all 2n plus 1 pi by 2 value, cos x will be 0. Therefore, secant x is not defined. Okay. Now, that is why we are taking r minus of 2n plus 1 pi by 2 to r minus of minus 1 to 1. Therefore, we restrict the domain to 0 to pi minus pi by 2 because you know that secant pi by 2 is not defined. and it will become 1 1 and on 2. Okay. Now r minus of minus 1 to 1, that you have to be very careful. Okay, well, now let us take the inverse function of secant x. It is from secant inverse x, r minus of minus 1 to 1, that is all real numbers except the numbers lying between minus 1 and 1, to 0 to pi minus pi by 2. Pi by 2 is not there, from 0 to pi. Well, now there are so many 1 to 1 and on 2 functions also. All these are called branches. They are all the branches of secant inverse x. Out of all the branches, we are taking one branch called principal branch as usual. Therefore, the principal branch is 0 to pi closed interval minus pi by 2. All the values lying between 0 and pi except pi by 2. Therefore, when we refer it as a domain as r minus minus 1 to 1 and range as 0 to pi minus pi by 2. Well, now this is the diagram for this. Let us see the secant x and secant inverse x now. This is the secant x graph and this is the secant inverse x graph. You are seeing that, and it is from pi to, it is there 0 to pi, and minus 1 to 1 is not included. Good. Then we are going to the inverse of cot x. As usual, cot x is not 1 1 on 2. We are converting it into 1 1 on 2 by removing n pi, and n goes to infinity, and n belongs to integer, r minus n pi, because tan n pi is not defined. Well, therefore for that we are converting it now. We are restricting the domain to 0 to pi. Both 0 and pi are not included, and the range as the r. Therefore, if you take this function f from 0 to pi to r given by f of x is equal to cot x, it is 1 1 and on 2, and this inverse is given by cot inverse x from r to 0 to pi. 0 and pi open interval. Now there are so many branches where they will be 1 1 on 2. So these are all the branches of cot inverse x, and from them we will take one branch which is called the principal branch. That branch is 0 to pi. Both 0 and pi are not included because cot x is not defined in 0 and pi. Well, therefore when we refer the function cot inverse x, we take it as a function with the domain as r and range as 0 to pi open interval. Now this is the diagram for that. Now let us see the full diagram of cot x. This is the cot x, and this one is cot inverse x. You are seeing that 0 and pi are not included in that, and all the values are coming out. Okay, well, now let us now go for some domain and range of the inverse trigonometric function at a glance. Therefore, if the function is sin inverse x, domain is minus 1 to 1, range, that is the principal value, branch is minus pi by 2 to pi by 2. For cos inverse x, minus 1 to 1, close interval 0 to pi. And for cosecant inverse x, r minus of minus 1 to 1 and minus pi by 2 to pi by 2 minus 0. Secant inverse x, r minus of minus 1 to 1, 0 to pi minus pi by 2. And tan inverse x is r from minus pi by 2 to pi by 2 open interval. Y cot inverse x is r and 0 to pi open interval. Now you have to remember all of them, because when we are doing problems, we want the answer which we are getting by solving any inverse trigonometric function. Final answer should be in the principal value branch only. If you are solving any problem of inverse trigonometric function, finding the value, evaluating, final answer should be in the range, that is the principal value branch. And all of you are seeing here, one thing we have to be very careful. Cos inverse x, secant inverse x and cot inverse x will never give a negative value as the final answer. Cos inverse x, secant inverse x and cot inverse x will not give a negative answer. That is the final answer cannot be negative. Well, let us move on to properties now. Before we go further, let us see the values of inverse trigonometric function. This is the value which we have seen in lower class of sin x, cos x, tan x from 0, pi by 6, pi by 4, pi by 3, pi by 2. They are useful for doing problem. I am now making a table for sin inverse x. Sin inverse 0, 0, sin inverse 1 by 2, pi by 6, sin inverse 1 by root 2, pi by 4, sin inverse root 3 by 2, pi by 3, sin inverse 1 is pi by 2. Similarly, cos inverse 0, pi by 2, cos inverse 1 by 2, pi by 3, cos inverse 1 by root 2, pi by 4, cos inverse root 3 by 2, pi by 6, cos inverse 1 is 0. Tan inverse x will make it some small table. Tan inverse 0, 0, tan inverse 1 by root 3, pi by 6, tan inverse 1, pi by 4, tan inverse root 3, pi by 3. These values you have to remember. Anyway, if you know the trigonometric function value, you are just getting from that only inverse trigonometric function values. These are all useful for doing problems. Now before we go for a problems, let us see some properties. First property is sin inverse of sin x is equal to x only when x is in the principal branch. Cosecant inverse of cosecant x is x if it is in the principal branch, and cos inverse of cos x will be x only for x belongs to the principal branch. Secant inverse of secant x is equal to x for only x belongs to the range, the defined range. Similarly, tan inverse of tan x is equal to x only when x belongs to the given range. Good. Similarly, cot inverse of cot x is equal to x. Well, now let us go to the next type of property. Suppose you have sin inverse of 1 by x, it is cosecant inverse x. Cos inverse of 1 by x is secant inverse x. Tan inverse of 1 by x is cot inverse x. These properties are derived from the fact that sin inverse sin of x, 1 by sin x is cosecant x, 1 by cos x is secant x, 1 by tan x is cot x. Now we are now going for another very important property. Suppose if you have negative values, then sin inverse of minus x is minus sin inverse x, tan inverse of minus x is minus tan inverse x, cosecant inverse minus x is minus cosecant inverse x. You have to remember only these three trigonometric, inverse trigonometric functions will give you the final answer as minus of the inverse trigonometric function. Now you have to be very careful now. Cos inverse of minus x is pi minus cos inverse x. Secant inverse of minus x is pi minus secant inverse x. Cot inverse of x is pi minus cot inverse x. Therefore, cos inverse minus x, secant inverse minus x, cot inverse minus x cannot be negative. Final answer will not be negative. Well, let us move on to questions now. In the exam, if they ask you evaluate, if they ask you find the principal value, both are one and the same. You have to find only the principal value. First of all, whenever you have any principal value, if there is any negative, first use the property and then adjust the negative. Then if it is beyond, if the value is beyond your principal branch, then bring it to the principal branch, then do the problem. Anyway, sin inverse of minus 1 by 2. The range will be from minus pi by 2 to pi by 2. I am taking y is equal to sin inverse of minus 1 by 2. Let me use the first property. Sin inverse of minus x is minus sin inverse x. Now, what is sin inverse of 1 by 2? Because sin pi by 6 is 1 by 2, therefore sin inverse of 1 by 2 is pi by 6. Therefore, the principal value is minus pi by 6. You are very well that minus pi by 6 lies in the principal branch. Then only the answer is correct. Good. Let us go to the next question now. They want the principal value of secant inverse 2 by root 3. Y is equal to secant inverse 2 by root 3. Now, if you are not that much very comfortable with the secant inverse, cosecant inverse and cot inverse, using one property, convert it into sin cos tan. Therefore, secant inverse of x is same as cos inverse of 1 by x. Therefore, cos inverse of root 3 by 2. And range of the principal value from 0 to pi. Good. I know that cos of pi by 6 is root 3 by 2. Therefore, the value is pi by 6. Now, pi by 6 lies between 0 to pi. Let us move on to the next question where you want tan inverse 1 plus cos inverse minus half plus sin inverse minus 1 by 2. Here all tan, cos, sin both all are coming. Therefore, tan inverse 1, you know the value. But before we go further, let us try to adjust that minus. Cos inverse of minus x is pi minus cos inverse x. Sin inverse of minus x is minus sin inverse x. Therefore, I am substituting that value. Cos inverse 1 by 2 is pi by 3 because cos pi by 3 is equal to 1 by 2. Sin inverse 1 by 2 is equal to pi by 6 because sin pi by 6 is equal to 1 by 2. Now we are simplifying. Final answer you are getting it as 9 pi by 12. Any number of problems you can do, but always remember if you use the properties, the principal value obtaining will be very easy. Good. Let us go to the next question. We want the principal value of tan inverse of tan 7 pi by 6. But remember, don't directly jump into the conclusion that tan inverse of tan x is equal to x. We cannot use it because this 7 pi by 6 is not in the principal value branch. Therefore, the range of the principal value branch of tan inverse x is minus pi by 2 to pi by 2. But we have to restrict that 7 pi by 6. How to do it? It is nothing but pi plus pi by 6. Pi plus pi by 6. 7 pi by 6 is pi plus pi by 6. We will use the all silver teacups idea which you studied in your class 11. It is pi plus pi by 6. Therefore, it lies in the which quadrant? All of you know. Therefore, tan is positive. But tan of pi by 6. Now, tan inverse of tan pi by 6 is pi by 6. Suppose If the value they have given is in some other quadrant, if tan is negative also, you have to put minus. All of you know how to adjust that minus, already we have discussed. Therefore, always remember, whenever they want the principal value of tan inverse of tan of something, sin inverse of sin of something, be careful. You should be very clear that the angle which they have given should be in the principal value branch. Good. Let us go to question number 5. They have given tan inverse 4 by 3 is equal to x, but they want the value of cos x. These types of problems normally comes in the exam. They will give sin inverse something, they want tan x. They will give cos inverse something, they will give, they ask cot x, like that. Very simple. We have been given tan inverse 4 by 3 is equal to x. Therefore, what is tan x now? It is 4 by 3. Very simple. By making use of the property of inverse trigonometric function. Therefore, whenever it is tan x is equal to 4 by 3, then it should be lie between minus pi by 2 to pi by 2. All of you know what is the range. Therefore, in minus pi by 2 to pi by 2, secant x is positive. I am just to want whether from minus pi by 2 to pi by 2 secant x is positive or negative. It is positive. Therefore, I am finding the value of secant x, because secant x will be obtained using a square root. We have to check whether secant x is positive or negative. But it is square root of 1 plus tan square x. Therefore, 1 plus 4 by 3 whole square, and I am calculating it as 25 by 9. Remember, this is 5 by 4. But remember, I am taking positive because I am very sure that secant x is positive here. Therefore, cos x is 4 by 5. Suppose if you are having a problem where the trigonometric function which you are going to calculate, if it is negative in that particular range or particular branch, then you have to take a negative square root of that value. Anyway, now the value of the cos x is 4 by 5. Okay, thank you. All the best. Success is dependent on efforts. All the best.